So we have the equation d big T d little t equals k times temperature difference. T minus TR, we're going to substitute 80 degrees for R. We're going to substitute the value that we just obtained for K. And we're going to note that I'm just now putting the negative sign in here. That should be negative. I think it will appear on your page as without the negative because I've already photographed this and posted it. I'm going to leave it there for people to pick up the error. Now what we have is an equation where we have one of the terms being the rate of change. So the rate of change is a function of the thing that we're taking the rate of change of. So that we have the rate at which t changes in the same equation with t. This is an example of what we call a differential equation. This is a derivative. Remember, when we take a derivative we differentiate, so derivative and differentiating and differential are all related. So it's an equation involving a rate or a derivative, and we call it a differential equation. Right now we don't have a clue as to how to solve this equation. Once we develop some rules for doing derivatives and integrals, we'll find that this is a fairly easy equation to solve. But right now we're not going to worry about how to solve it. Now a more general form for a differential equation might be d big T d little t is a function of t, big T. That's not the only way we could have a differential equation. The d big T d little t could be a function of both big T and little t, or just little t. Okay? It could be a function of either the variables in the derivative. The numerator variable or the dependent variable, the denominator variable, the independent variable, could both appear in this function. This function shows no dependence on little t. It's only dependent on big T, but it would still be a differential equation if there was a little t here. This differential equation has a solution. And I'll just note that that solution is an exponential function of t. The temperature big T is an exponential function of little t. When we solve a differential equation of either of these types, any equation involving a differential, the solution is the function of t, or the function t. We're trying to find the function here, much like when we integrate a rate function, the answer is a function. Okay, we think of integrating a differential equation and getting the function. Much like integration. Again, this particular differential equation gives us an exponential function of t. Had the function, or had the proportionality been proportionality to the square or the square root, we would have had a square of t minus 80 or square root of t minus 80. We'd have gotten a different constant in those cases. We would not have gotten exponential functions. One of those equations will give us, in fact, a quadratic function, the one with the square root in it.